Hello and welcome to Basic 2 Tech for students, teachers, and math education. In today's video, we shall be looking at algebra, and the topic for today is how to identify functions. A function relates an input to an output. In other words, we can say that the input is an independent variable while the output is dependent on the input. So the output is a dependent variable. A function is written in this form: f of x, for example, equal to x squared. So a function has three parts. It has input, which is x. X is the input. This is the output. So whatever we get from this is the output, and the squared is the relationship. So a function can be written in this form. The f in the function is called the function name, while this again is the input, and this is what to output. So whatever we get from s squared is the output. For example, if x is 2, for example, so therefore our f of x is 2, so our f of 2 is equal to x. So I replace x with 2, so we now have 2 squared. So what is 2 squared? 2 squared is 2 times 2. That gives us 4. So f of 2 is 4. So therefore 4 is our output. So this means that the input again is related to the output. So we can say 2 is related to 4. So the 2 is the input and 4 is the output. Some examples of functions are f of x equal to, for example, x cubed plus 1. It can also be as f of x equal to cos of s, or it can be of f of x equal to sine of x, and also it can also be written as f of x equal to tan of x. So these are some examples of a function. There are also other functions that are written without the f of x. For example, y equal to x plus 1 is a function, just that there's no f of y written in front of this. So again, x here is the input, the y is the output, and this x plus 1 is, and this is the relationship. Now let's look at how we can identify a function. We have three ways that we can know if we have a function or not. When a function is having a one-to-one, for example, how do we know a function? When we have one x value to a y value, that is a function that is called one-to-one. When we have more than one x value to a single y value, that is called many to one. These are functions. For example, as you can see right here, we have in the x, here is the x values and here is the y axis. So we have one x value to one y value, we have an x value to a y value, x to y, and we have two x value to a single y value. So these are called functions. As you can see right here, we have 2 to 1, that is many to 1. So these are all functions. So It means that for us to have a function, x value must be mapped to a single y value, or more than one x value must be mapped to a single y value. That is a function. In this case, we have one x value to more than one y value. This is not a function. When you have one x value having more than one y value, that is not a function. It is called one to many, and it is not a function. Also, functions can also be written in tables, as you can see right here. Here is the x values and here is the y values. They can be written as functions. The x values are called the domain, the y values are called the codomain, and the values in the y-axis are called the ranges. So as you can see on the table, we have 1 to 1, we have 1 to 1, we have 3 to 9, yeah, we have 3 to 9, we have 4 to 16, 4 to 16, we have minus 4 to 16, minus 4 to 16, and we have 0 to 0, which is right here. This is a function because we have 1 to 1, and we have many to 1. So this is a function. So we can also write functions in tables. Please remember that the values in the x-axis are called the domain, while the values in the y-axis is called the codomain, and the values in the x and the value in the y-axis are called the ranges. Now, a function can also be written as a set of ordered pairs. For example, we have let's say for example we have 2 comma 4, we have 2 comma 4, and we have 3 comma 7. This is a function. Remember, these are also called coordinates. The first value is the x, next is the y, here's the x, the y, x, and the y. So this means that x value is mapped to 4, x value mapped to 4, x value mapped to 7. This is a function. All right, as you can see right there, we have 2 to 4. Again, we have 2 to 4. We have 3 to 7. This is a function. When we have one or two x value having more than one y value, that is not a function. But what I want us to learn from this is that a function can also be written as sets of ordered pairs, which are called coordinates. And with this, we can plot a graph using these values. When given a graph, we can also find if it is a function using what we call the vertical line test. Now, on a graph, the idea of a single value means that no vertical line ever crosses more than one value. If it crosses more than once, it is still a valid curve, but it is not a function. As you can see in this case, the vertical line is crossing more than once. That means that it is not a function. So for you to test if a graph is a function, you have to draw vertical line on the curves or on the graph. If the vertical line crosses more than once, that means that it is not a function. Remember, it must have a single value in the y-axis. Let's look at some examples. It says, what is the output of the function below if x is 3? The function is given as f of x is equal to 1 minus x plus x squared. And we're given that x is 3. So that means that we have to substitute x for 3. So therefore we have f of x, which is 3, f of 3 is equal to 1 minus x is 3 plus x squared, which is 3 squared. So we have 1 minus 3 plus 3 squared is what? So 3 squared means it means 3 times 3. That gives us 9. So 3 squared is 9. So therefore we have 1 minus 3. 1 minus 3 is minus 2 plus 9. That will give us plus 7. So it means that f of 3 is equal to 7. That means that 3 is related to plus 7. Let's look at our next example. Which of these is a function? Let's call this A and we call this B. Which of these is a function? Look at A. We have 1 to 2, 1 to 3, 3 and 4 has no values in Y, and we have 5 to more than 1 x, more than 1 y values. So this can be a function. And also remember that a value in x axis must not be unattached. They must have a value in the y-axis. So this is not a function. Look at B. We have 1 to 1 here. We have 1 to 1. We have 1 to 1. We have 2 to 1. So this is definitely a function. Here is the next question. Which one of the following is not a function? Now, here is a graph. For us to do this, we have to apply the vertical line test. The vertical line test. So I can bring out my ruler and let's start with A. So I can try with A to see if A is, so this is my, let's try and see. We can draw the line on it. Let me use a red pen, a red ink. That is just a single point. Let's try this. It's a single point. So A is a function. So A is a function. A is a function. So let's take it off. Let's try. Let's try B. Draw a line. Oh, B is not a function. As you can see right here, B is not a function. Why? Because we have the vertical line is crossing more than once on the curve. So this is not a function. So therefore, B is our answer. So B is the answer. Here's the next question. I want you to pause the video and see if you can tell us which is not a function. All right, welcome back. So, which is not a function? I believe you guessed right. Look at A. A, we have 1 to 1, we have 2 to 4, we have 3 to 9. In A, every element in X has a relation in Y. So this is the X axis, this is the Y. So A is a function. So it's okay, A is a function. Look at B. B, we have 1 to 2 values in the y-axis. We have 2 to 2 values in the y-axis. So B is not a function. This is called 1 to many, and that is not a function. So this is our answer, because the values in X has more than one value in the y-axis. Remember, a function must have a single value in the y-axis. Look at C. We have 1 to 1, 2 to 1, we have 2 to 1. This is a function. Look at D. We have 2 to 4, we have 3 and 4 to 9. This is called many to 1. that is a function. When we have one to many, that is not a function. So that makes B the answer to this question. So thanks for watching, and we'll see you in the next video.